Hi guys, welcome back to the Tech Garage. Today we are going to be covering part 2 of linting in Android projects. If you never got a chance to check out part 1, I'm going to link it down in the description box. And just as a quick recap of what part 1 was about, in part 1 we covered what linting is, the importance of linting, and the tools available to us as Android developers to perform linting. The first tool we mentioned was Android Lint, which comes automatically integrated into our Android Studio. The second tool we talked about is Ktlint, and we also did a quick integration into a demo application in our part 1. And if you go through Ktlint, you will notice that it checks your code against rule sets that are mostly focused on styling and formatting based on Kotlin conventions. And as an Android developer, you probably want to take this a step further and get a tool that also checks more than just styling and formatting. So these can be things like code smells that make your code harder to maintain or less performant in the future. A simple example can be very complex classes or complex methods. If you have a method that is so long but could easily be broken down into smaller units that are more readable and easier to manage, then if you have a tool that checks that, that really enhances and helps you in how you go about writing your code. And for that, for Android projects specifically, we have a tool that you can use called Detekt. And Detekt is a code analysis tool for Kotlin projects, and it has a wider range of rules as compared to Kotlin, and also spans way past just formatting and styling to look at things like complexity, just as we mentioned, like complex classes and methods, checking for code smells, or things that could potentially cause bugs in your project in the future, that you're probably not aware of. So I can probably pull the documentation so that we look at some of the rules that are available. So if we go to the rules documentation here, you can see all these rule sets that are available for Detekt. There's the comments rule, complexity rule, coroutines rule, empty blocks rule set, exceptions, all these rules. There's potential bugs rule sets, all these kind of rules. So let's look at, let's say, complexity rule set. So this rule set has all these rules available for you to use, and we can probably just open one and look at it. I'm going to open the long parameter list, and this rule says reports functions and constructors which have more parameters than a certain threshold. And the function threshold, the default is 6. The number of function parameters required to trigger this rule. So if you have parameters that are more than this, so you have 8, 10 parameters in a function, then this rule will be flagged by Detekt as a violation in your code, to avoid having methods that have too many parameters. That makes it less readable and harder to maintain over time. So that's an example of a rule that Detekt has. Let's look at potential bugs rule set. And yeah, these are all the rules available for you in the potential bugs rule set. You can look at probably one. Avoid referential equality. Kotlin supports two types of equality: structural equality and referential equality. While there are use cases for both, checking for referential equality for some types such as string or list is likely not intentional and may cause unexpected results. So non-compliant code in this case will be the one that is using the referential equality, which is 3 equal signs basically, and the compliant one will be this. And a good example of where this rule flagging can be very useful is for that I've encountered is unit test. So if you're writing unit test and you probably want to compare the contents of a list for the test to pass, if you use this referential equality, your test may fail because referential equality checks for the memory address to compare if it's the same, which is basically checking if these two lists are the exact same object. But in your test, you wanted to compare the contents of this list so that if it's the same, your unit test is passing. So in that case, I had a test failing, but really it should have passed. The problem was just like it wasn't checking the content of the list, but if the list is the exact object, if that makes sense. But yes, that's an example of where this can be a good rule. Let's look at probably another rule, else instead of exhaustive when. So this rule reports when expressions that contain an else case, even though they have an exhaustive set of cases. Let's look at what will not be compliant. So you have an enum class color that has red, green, and blue, and then you have a when case that takes that enum class, and you're handling when the color is red, do that, when color is green, do that, else do that. So you're not handling the blue explicitly, so that's non-compliant, and it will force you to handle every single instance of the enum class or sealed class exhaustively. So it forces you to handle every single case, because sometimes you may have the else. As you add more items into your class, you will miss handling a case that could potentially lead to a bug in your code. So this is a simple example, but in a more complex example, if you keep adding things here, you may forget to explicitly handle what's supposed to happen when it's maybe that other color. So that's another example of, yeah, the potential bugs rule set. So as you can see, we have a wider range of rule sets, and they provide way more than just styling and formatting, which we had in Ktlint. So probably a worthy mention is for the formatting rule set. If you check here, this rule provides wrappers for rules implemented by Ktlint. So to be able to use this rule set and pull the Ktlint formatting rules into Detekt, you have to add this as an extra dependency in your code, and you'll have the formatting rule set from Ktlint. So based on that, you may ask, then why do you have to implement them separately? So the reason I did a part 1 and a part 2 for this is uh, for most projects, you can still implement them separately and they work perfectly, which is how I have implemented the projects I've worked on. And the other reason I also implemented the separately as a part 1 and part 2 now in this video is I saw a discussion on the Detekt code base where the maintainers wanted to remove this wrapper. So if you go to the Detekt GitHub page, there's this discussion to remove the Ktlint wrapper as part of Detekt. So which may force you, if you want the formatting from Ktlint and also to have Detekt, to implement them separately ultimately. So I'm going to link also the discussion so that you guys can check it out and probably play around with just having Ktlint implemented directly into Detekt if you want to try it out. But yes, so that's mostly about the rule sets. And the other thing is the rules are also very configurable in Detekt. So for example, a rule that you're looking at, for instance, the long parameter list rule, it has the threshold of 6. We can choose to configure this and say, I don't want you to flag my methods when they have 6 parameters. Start flagging them when they have 10 or more parameters. So you can choose to change the threshold value to something that suits you based on the needs of your project. So the rules are very configurable for you in the rule set if you want to change them. And yeah, so that's it in terms of a quick introduction to Detekt and what it offers your project. So we can just jump into integrating it to the other project that we had that we integrated Ktlint on. So I'm going to pull up Android Studio. And yeah, so this is the same project that we had for Ktlint. The app runs and shows a basic text that just says you ran the Techie Garage episode. That's on Linting in Android. So it's a very simple application. And yeah, so to integrate or add Detekt to your project, first of all, you'll need to add it to the project build.gradle file. I'm going to just pick that and sync. And then we want to add it to our module level, which is the app module as, again, our plugin dependency, and give it a bit of time to sync. As the project finishes the sync, worthy mention from the documentation is probably as you add your dependency on Detekt, check the compatibility table to make sure it's not clashing with the Gradle version or Kotlin version you're using. So as part of the documentation, they have the compatibility table right here. So be sure to check that bit out. Yeah, so let's go back to our project and sync for the second dependency we added. And yeah, so we are done with the sync. So once you integrate, you add the dependencies, you now have a new Gradle task that allows you to run Detekt. Just as for Ktlint, we were getting two Gradle tasks. So we were running Ktlint format as a Gradle task and another Gradle task called Ktlint check. So in this case, you have another Gradle task added called Detekt. We can actually check it from here. So if you check configurations, you can see Detekt here. There's also another task called Detekt generate config and Ktlint format. Yes, same case for the app module. So you can choose to run it from here or the CLI. So I'm going to run it from, sorry, from my terminal, Detekt. So this is what you use to run for it to perform analysis and give you the errors that you have in your code. So we'll go ahead and run it so that we see what issues we have. Allow me to just close this. Okay. Okay, and here we can see all the issues that have been flagged. From the part one, we had so many issues when it comes to formatting and styling, but because this project we already integrated Ktlint and ran and fixed all the issues we had, you can see we probably don't have too many errors. The issues that, or the rules that are being violated are this function naming. I can see function naming in 2 files appearing 3 times. The rest is the same rule called magic number multiple times. So a lot of the errors already fixed in terms of formatting and styling already fixed by Detekt. So let's go ahead and look at some of the issues we are having. So for main activity, function names should match the pattern. So let's go straight to the file that's complaining. Function names should match the pattern that's for function naming. And again, this, in terms of function naming, is the convention for having functions in camel case. But again, for composables, the convention is to have them in Pascal case. So these should ideally not be flagged. And to fix that, because we don't want to have this in camel case like this, since it's a composable, we want to configure this role to not flag composable functions specifically. And if we check our documentation here, Detekt has specific configurations for compose. And yes, at the top, we actually have function naming. So composable functions that return unit are named using Pascal case. Detekt may see this as a violation. So the recommended configuration is set ignore annotated for composable functions. So we are going to go to our rule, back to our file. So yes, the other bits to mention is how do we now go about configuring our rules, probably to enable or disable or configure it to our liking. For us to be able to do that, for instance, for this function naming, we are going to run the other Gradle task that we saw. So generate config. So what this rule does is it generates, let me quickly open the project structure first of all. So this config directory is not usually there when you start the project. I wanted to navigate so that we see it being added by this rule, but yeah, I guess I navigated too late. But this doesn't come by default in the project. So when we run this rule is when this config directory was added, and it will contain the detect configuration file. So Detekt uses a YML file for the role configurations. The moment you run this, it creates your config directory and your YML file, and the YML file will contain all the roles that Detekt is using to go about code analysis on your code. And now you can change and configure them based on your liking. So the rule you are looking for is function naming. Function naming, yes, we are looking for this function naming role, and currently that rule is active, and what we want to do is configure it to specifically ignore composable. So we've seen the property for that is called ignore annotated. So we want it to ignore specifically anything annotated as a composable. So yes, so let's run this again and see if the issue of function naming is appearing anymore as a flagged violation. Okay, so so if you check here, you can see now the function naming rule disappears because it was flagged mostly on the composable functions, and we fixed that. So the next issue we are having is the magic number rule violation. So it says this expression contains a magic number. Consider defining it to a well-named constant. So let's go to where the thing is complaining. So because we have a number 3, and you need to probably define what this represents. So another example of where this rule applies really well is probably where you have random integers in your code. So for example, an integer you may have is an integer that holds the amount of time for a timeout for a request. So you're just passing it directly to a function, but you could have named it to a constant that is more readable and exactly explains that this constant is for timeout, right? So a way to fix this is instead of actually defining it as a constant, is passing it as a named argument. So if I put number, so this is supposed to be the number of the episode, I can also just make this a named argument. So yeah, so now it's very clear that this 3 represents the number, the episode number, this represents the topic. So this should not be flagged anymore. So we are going to run detect again and check that. So let's run detect. And yeah, so the flagging on the main activity is now gone. The only issue we have is now in this next file, the color file. And for this also, you can do exactly the same thing just by making your argument named. So live equals to that. So if we run this again, and you can see now all our rules that were being violated are now fixed, and your detect is successful. Probably you can also go through the other configurations available for compose. I can also see there's actually one for magic number. Apart from naming your argument, what else you can do? There's the ignore property declaration should be true. Ignore companion object property declaration should be true to fix this magic number actually in the color file. So if you're using this in Android and you're having issues with Compose, feel free to check out the documentation on this bit and see how to configure rules to work specifically for Compose elements. And yes, that's generally how you go about implementing Detekt. That's how you go about implementing Detekt. I wanted to just run and see if there's a specific rule here. Just a bit. Okay. That's just how you go about implementing Detekt. And the other bit that I have found Detekt really useful for, apart from flagging rules and violations, is the violations you have on the rules is you can also use it to instill practices in your team. So if we go to practices like documentation in your team, if you go to the config file here, you have rules that are not enabled by default. There's a rule for documenting your classes. There's a rule for documenting your functions. So you can see a rule called undocumented public class, and it's currently not active because it's set to false. But if I set this to true, that means every time I run detect and there's a class that is created by any of the team members that's in our code base has to be documented if this is something that we want to instill in our team. So if I run this, let's run detect again now that we've activated this class. You can see detect fails, and I'm forced to document or give a documentation for what this class is about. So I can just give entry point displays success message text. And if I run detect again, now that I've provided documentation for the class I have, it shouldn't flag my code base anymore. So these can also be used to enforce documentations in your code base in a team setup. So you can go through all the other rules and check the ones that can be useful and activate them. So you have the one for the public class. You can also choose to have your team document also for functions. Currently it's set to false, but works the same way as the undocumented public class. But yes, that's basically how you go about integrating Detekt. And you'll probably notice that for both Ktlint and Detekt, so it may look like for part one and part two, it looks like probably there are so many rules that you need to keep fixing. But if it's a completely new project and you set these two tools as the base, then and fix all the issues that come up, then moving forward as you add code into this code base, you just fix the violations on the files that come up. So it's very easy to work with them as you go. If it's an already existing code base, you can also choose to configure them to only flag specific directories. So you can say, I want first of all to start integrating Ktlint and Detekt or fixing issues in this first module. Then for this next modules, I will fix them incrementally. So you don't have to you won't be forced to like fix the issues in every single module if it's a very large code base. So you can start with one module, fix the issues in that one, next week pick another one, and so on and so forth. So yeah, that's just mostly it about Ktlint and Detekt. I hope you guys get to try it out in your project and give any feedback on interesting rules that you found on both of the tools. You can open an issue on the GitHub repository that I'll link below for this project if you have a very interesting rule that you use for your team. And yes, that's mostly it about Detekt. If you watched up to this point in the video, thank you so much, and see you in the next video.